Hello, everyone. Give me a thumbs up if you can hear me. I want to welcome you to another session of our Technomatics virtual user group. Awesome. My name is Taryn Blake. I'm the Community Engagement Program Manager for our DISW community. And we are here today with a session on free driving AGV basics for plant simulation. As most of you know, our speaker for this series is usually and is today Mr. Stefan Bangsau, who is a freelance simulation expert. He has been in this field for quite some time and done hundreds of projects and training sessions. For us, this is the 20th training session for Siemens plant simulation and Technomatics. And so we're very grateful to have another session today. Stefan has 5 books published on plant simulation, and I know he is currently working on a 6th book. So we appreciate his contributions to our Siemens PLM community. Today, the 3 big steps for the meeting are AGV pool and markers, creating requests, and AGV controls. So as many of you know, Stefan always presents completely live. So you can follow along if you have your software open, and you'll get to watch him troubleshoot as he moves along. And then, of course, we will also live have our Q&A afterwards. If you have noticed, there is a hand raised button. It should be in the top middle menu. You're right next to the reactions. So you can use that when we get to the Q&A. So if you raise your hand, we'll take you off mute. You can ask your question more easily. But of course, you can also use the chat to ask questions at the end. So take notes. You can put the questions in, as we go along, and we'll get to all of them when the tutorial is finished. So that is my last statement. And Stefan, you can take the screen.
Hello again. Okay, today we will deal with the basics of free driving AGVs. There will be other webinars with the topic of AGVs, and so it's just a starting point. We had already one for track-based AGVs. You can have a look in the recordings. They should find the recording of this webinar. Okay, we start with a very simple model here. We need one source. The source produces parts. I want to have one station. And I want to connect the station with a train, so we don't produce a big jam here. And we need, for the free driving AGV, we need some stuff from the resources folder here. There you can find the AGV pool itself. And the AGV cannot drive completely free on the surface here. We need an element with the name marker. And I want to have 3 different markers. I switch here, navigate, open origin. I want to have the names of the marker for you here. So I make the names visible. Okay, I want to have 4 markers, 3 markers, one marker 1. I want to have a second marker near the machine, marker 2, and one marker 3 here in this position. The HEV should have a very simple task. The HEV should come out of the HEV pool, goes to marker 1, loads one part from the source, goes to marker 2, unloads the parts here to the station, and then via marker 3 back to HEV pool. For this, I need a control. So I need a method. I name it HEV control. And I want to have an init method to call this method for the first time. So I take a second method, rename it to init, and here we start. First is quite easy. You may have other stuff here into the init method. So I call this if HEV control point execute the call chain. So that this method is calling with its own call chain and doesn't hold here the init method. And so we can program one loop for the HEV here and this HEV control. At the end of the HEV control, we call the HEV control itself so that we have a closed loop. First, I want to have a variable of type object. And this HEV, I have only one HEV, and so I can take amuse here, transporter. If I only create one, then this would be the transporter 1. There are some other ways to call the HEV via the HEV pool, for instance. But for this very simple example, I can do this in this way. And the first step is go to source. The most important command for the HEV, for the free driving HEV, is set route. HEV point set. I need to set here an array of markers. The HEV itself only can be located on objects of type marker, tracks, and the HEV pool itself. And so I'm quite restricted. I cannot drive, for instance, into a buffer. In our case, he has to go to marker 1. And then I need to wait until this HEV has reached its destination. And for this, the HEV has an attribute, destination was reached. And this attribute will become true if the HEV has reached its destination. And then maybe I wait 5 seconds, and then I load the part from the source. Okay, there are not so many commands that you need to remember here. I can test this. HV comes and loads one part, and then my program stops here. Now it's the marker itself has one option, use rotation of marker. Activate this for this marker here, and then you can turn this marker, hold down Shift, Control Shift, and then you can turn this marker with the direction keys on your keyboard. And if I try it again, then the orientation of the of this HEV in front of the source will change. And the same you can make here on for the marker near the station. Open this marker and then activate use rotation of marker. For this marker, it's okay. And here I don't need it. Okay, first step. Next, I need to go to marker 2. And so I can copy these lines here. Go to marker 2. And then I need again to wait until the destination was reached. Again, I wait some seconds. To have the unloading time, and then I move the part from the HEV to station. And finally, I go back to HEV pool. And again, it's set route. And here the route consists of 2 elements, marker 3 and HEV pool. And then I wait until the movement is finished and I start again. Apply the changes, and then I can test this here. Reload the part, go to marker 2, unload the part, and via marker 3 to the HEV pool, and then I recall all the stuff and the next cycle starts. Some common questions here. Do the HEV avoid collisions? We can test this here. I place a station here and start. No, HEV doesn't identify any objects on his route, and so you need to set the markers in a way that the HEV doesn't collide with any station or equipment or wall, or what you have to consider here during the routing of the HEV. Now you can also, as root, you can set objects, but with the newest version, you can also set positions here. Have a look in the help how to do this. And this is the first example I want to show you. Special problems you have if you have several HEVs, then you need some control. Okay, who is getting the job here? And you need to create like a fleet management system. But this would be another webinar in February. Okay, starting, I guess, with version 23.02, you can connect markers with connectors, and then you can use the root finding functions of blend simulation to let blend simulation find the shortest route to the destination for you. And for this, I want to make another model here. And so I create a new model frame. I close this. And we make another example. In this example, I want to distribute three different parts to three different machines by an HEV. And so first I want to have three different parts. I duplicate part and rename it to A. I make a second one, duplicate B. I open here the 3D properties. And in appearance, you can change the color. Just activate the material here and select a color. And I need a third part, part C. And the same, change the color of this part, edit 3D properties, tap appearance, activate the material, and then select a color for this. Okay, and one source should create these three parts in a sequence. And so I need a data table here to hold information for the sequence. Drag the table onto the source. Then it becomes here MU selection sequence cyclical, and the table will be here inserted as table. Blend simulation will format this table now and then drag the three parts into this table, part one, A, part B, and part C. And I want to set in this sequence one part E, one part B, and two parts C. Okay. I want to have three stations. First, I set here 3D properties the captions active here, so I can see the names of the stations. This should be a station 1. Station 2 and station 3. And for the routing, I want to have a net of markers. And so I go here, resources marker, and again, edit 3D properties, tab captions, and activate label. Okay, it's already. I start here with M1. This is easier in the planning view. M2. M3. M4, M5, and M6. And then connect the marker in both directions. In this direction, back. Into the HAV pool inside here and connect it with M1. And then we need a drain, one drain for all 3 stations. If the HV can drive here between M2, M5, you have to connect it, this also in both directions. So Plan Simulation can use this to find the shortest way. If this is not possible, because maybe here are located some stations and machines and you cannot drive here in this area, then you can just not connect these markers. Okay, now I want to distribute part A to station 1, part B to station 2, and part C to station 3. And so I need, again, HEV control. Again, this very, very simple example, only with one HEV that distributes all parts to the machines. So we don't need to program fleet control and don't need to decide what HEV I want to use here. And so the same constellation, I create one method for the HEV control. And I want to have one init method. To call this method for the first time. It's the same like in the previous example. HEV control execute new call chain. You can have a look in the transporter here. Go to tab routing, and by default, automatic routing is activated. And to use automatic routing here in Plan Simulation for transporters, we have to set the destination. We don't set a route, we set the destination, and then Plan Simulation will look for the shortest path. And then we have to wait until this the HEV has reached its destination, and this is the same way like the free moving HEV without route finding here, its destination was reached. And so it's slightly different how to program this here. You cannot set a route. We have to use the destination attribute of this transporter. And so we start with the HEV control. I make the same here. I can show you, I guess, a very interesting failure. HEV, I take the transporter here. And the first instance is transporter 1. And then I want to drive to source. And this I start with destination. M1. You don't need to start the HEV. If you set the destination, then Plan Simulation will start the HEV and drive to this destination here. And then you need to wait. Until this destination was reached. Okay. I stop here and want to try it. So let's start this. HEV coming here and is stopping without any additional command. You don't need to stop it. It stops by themselves, and here it loses the setting for the destination because here this is active, and it's better to keep it in this way. The destination will be delayed if it reaches here this marker. Okay, let's continue. Then I wait a little bit for the loading time of the HEV and load one part from source. And then I need to select a destination. Depend on the name of the part on the HEV. And I can use a switch command to do this. I want to switch depend on the name of the part, HEV current point name, and I have 3 different cases. Case A, HEV point destination is M6. I hope so. Yes. Second case is case B. And then it's M5. And case C is destination M4. And again, we need to wait until the HEV has reached its destination. And then we need to load the parts to the stations. We don't have a connection between the marker and the stations here. And so we need to look, okay, we are locating on M6, for instance, and then we need to load on station 1. And so I can again use a switch command here. Switch HEV location point name. Now the HEV is relocated on the markers. If you move it here with destination, and so I can select my cases. If we are located on M6, then HEV point current point move. Then I move the part to station 1. And now I can copy and paste. If we are on M5, then the part goes to station 2. And in case of M4, the part goes to station 3. And end. And then I can restart. With execute new call chain, I restart this method, and this method will be finished after this. Okay, let's check it out. Port E is going to station 1. Port B to station 2, and then two times C to station 3. Okay, if you want to have another behavior that the HEV is turning on these corner points here without moving forward, then you can set the default transporter routing, the default curve radius to 0, and then the HEV will behave a little bit in other way. Now it turns with the set speed. Okay, so we have two slightly different kinds of approaches for control HEVs, free moving HEVs. The first one is with set route. You can set a route, consists of auger pool, markers, track segments to reach the destination. And the second one is if you connect all the markers in the right way, you can just set the destination of the transporter, and and plan simulation will plan a route by themselves to the destination and look for the shortest path. And I want to show you a very interesting failure here. I have two models here, and I start the first model. Okay, stop it and close it. And then I start this model, and I get an error here. HEV destination M1. MMOOST transporter 1 cannot reach its target position. And I don't have here, there's no HEV in this frame. The problem is I switch on graphics for content. Okay, in this way I can show the HEV that's here. If you have on another model here an HEV, then this HEV is transporter 0.1. This is the first instance. And if you start another model, and then this becomes transporter 2 on HEV pool. And this HEV1 here is it's in another frame, and so you get a strange error message because in the other frame the transporter is not connected, the marker are not connected, and so you cannot reach M1 because no M1 is here in model 1. In the model we don't have M1 here, and so you get an error message from this HEV in this frame in the other frame, and this causes a lot of trouble if you make the access like this one here, transporter 1. Maybe this is transporter 2. And so it's better to access the HEV in another way, not directly with the instance number. You can use the HEV pool for this. And there are two different ways with get assigned HEV. You can access, for instance, the first HEV in the HEV list. There's a get assigned HEV list here, and there's a method get idle HEV. And in this way, I can avoid these problems if I have several models and there's still HEVs in the other models, then we will not access this HEV from another frame. And so it's not a good way to access the HEVs with their IDs. Okay, I think there are coming more changes and more enhancements in the future versions of Plan Simulation. We will do several topics here in the webinars next year. For instance, how to manage several HEVs, how to manage collisions between, or how to deal with collisions between several HEVs, and some topics with how to connect HEVs, for instance, to robots, how to connect HEVs to Worker. These are several topics we will handle here in other webinars. Are there questions?
So there is one already in the chat, and someone has given it a +1, and they're asking if there's more than one AGV, is there a way to claim a route so that they don't collide?
Only if you program this. The HEV will not recognize each other on the way. There's a way to create some controls here. There's a distance control, and you can define several zones. And if there's another HEV comes into these zones, then the distance control is called, and then you can create some actions. But if you have several fixed routes and you want to have only one HEV on the routes, then you need to block the routes with your programming. And so it's not automatically until now. Maybe there will changes in the future.
And the next question was asking, can the AGV methods used in plant simulation be exported to, I guess we'd pronounce it CMove, right? So this is another piece of software that Siemens has. So I don't know if you're familiar with it.
Yeah, but you need to check the syntax between these two. Not directly, no. Plans SimTalk, it's really a special language only for plant simulation, and so you cannot exchange the programs between different Siemens programs. Yes.
Mute, but there is another question in the chat. So is it okay to change route or destination while the AGV is somewhere on the route? So it hasn't reached the destination yet. Is that okay?
Not yet, maybe in the future. So you don't have, in the meantime, now with Plan Simulation 2404, there are methods here. You can set arrival arrival controls in the marker. And this arrival method control will be also called if you hit this marker on the route. And so you can stop the the HEV here and create a new, a new destination, but not in between. Somewhere in between two markers, there's no way to stop it. Maybe with a time distance. But as I said, there are a lot of changes on the way, and maybe this behavior will change in the future.
Okay, so along those same lines, a question came in. If there are shared routes and shared zones between AGVs or fork trucks, how can we use the marker and connectors such that they don't collide? So definitely seeing a theme here.
Yes. Okay. Depends on your controls you have. You may use several like a sub route to a traffic light, and then check on this marker if the traffic light is red or not. But then the HEV will stop here, and so you need some stopping points where you can call the arrival control and then check, okay, the next the traffic light is red, and so I need to stop the HEV. But you need to program actively the zones and your blocked zones. But here I want really to look how is it done in reality. Do you have some technical stuff where you can see, okay, what's on the way? Only HEVs can collide with each other, but it's, I guess, much too late if you let the HEV come together quite close, that the distance control is be called. And so I guess you need an overall control for this to block several markers maybe, and then you check on a marker if the next marker is blocked, and then you need to stop and wait until the next marker is not blocked anymore. But it's really, it's your duty to program this until now.
Well, that's a good answer. While people are thinking about maybe their next question, we do have about 10 minutes left. I want to share a slide with the audience just to give you the link to the forums where the recording for this and our previous sessions are where they exist. So you should see now on your screen the link to, it's a screenshot of the forums, what they look like, and there's a hyperlink that you can click on right now. If you've never been there, it will take you to the page in the image. So on that page, that is where we post the recordings for this session. It will be there by Friday. And it's also a place where we post, Stefan will post the model that he worked on today. You can ask additional questions anytime. So you can go there in the forums and mention Stefan. We have some other experts from Siemens and other super users like Stefan who can answer your questions specifically about any of the sessions that we've had for plant simulation with Technomatics. So definitely wanted to make that available to you, and you should see the animation. It's showing you that we recommend you follow the topic, and that after you click the follow button, that you click to subscribe to every post for email notifications. So that way that you'll get an email as soon as we put the registration link for the next session, and as soon as we post a video recording, that you'll receive an email. Okay, so it looks like we do have another question before we go. Yes. This person's asking, can AGVs drive on ramps and different decks? So for example.
Yes, they can. Plant simulation has HEV lift now. Just try to change the set coordinate of the marker, and the HEV will follow the height of the marker, and so you can
And is that something you can show on the software?
One moment. Yes, so I take the model, and then I take the marker here. Edit 3D properties. I change the set position to 3. Okay, and then set root. Cut 2, marker 1. It's the same problem like this here. I need to and now it drives. You just need to change the height of the marker. Just change here 3D properties, the set position of the marker, and then the HEV will drive like on a ramp here to the higher position.
Looks good. Now, there are some folks in the comments who are asking about practice. So someone said for offline practice, is there an online platform that you practice on?
Oh, yes, you can practice in our forum. There are so many questions and you can read so many forum articles and download the test license of Plan Simulation, and then you can try all the examples from the tutorial, for instance, for a starting point. And there's a step-by-step help in Plan Simulation. And I have a book called Plan Simulation, and in this book are almost 300 examples you can test and you can try.
Everything that you need is available, yes. Definitely.
Are there example models in Plan Simulation for HV using collision control and traffic lights? There will be a webinar. Have a look in the forum, in our Plan Simulation forum. There are knowledge articles here, and have a look there. Somewhere there's a collision control. Simulation-based collision detection here.
Thank you. So yeah, what Stefan's showing on the screen right now, you can definitely go there and ask questions. He makes himself available as well. You can mention him, so you can see his profile there on the screen, Stefan Blanksau, by using his name. So definitely go to that page, Technomatics Plant Simulation, and then we are, I think, yeah, if you click Technomatics, and the very specific area that Stefan's always in is the Plant Simulation Virtual User Group. So we have almost 100 followers. If 2 more people go there right now and follow, we'll be at 100. So thank you so much, Stefan, for this lesson. Seems like it was answering a lot of questions for people. We appreciate everyone coming on live today. And as mentioned, you can find the recording using the links that we've given you in the chat and shown on the screen. So it will be there on Friday.
Thank you.
Yeah, that's it. Bye, everyone. Merry Christmas, Happy New Year.
Yeah, until next year.
Yeah.
Goodbye.
Bye.